Today, what we'll do is we'll continue with the previous session which we had on hypothesis testing. Today, we'll try to cover two types of hypothesis tests, typically known as C test and P test. So we will see what these tests are. We will take a couple of examples on both and understand how to calculate Z score and T score, and from these scores, how do we make a decision of either to reject the null hypothesis or to accept the alternate hypothesis. So that would be the broad session today. So first, let's start with Z-test. So Z-test, as most of you know already, so they are basically a way to test our hypothesis. We calculate something called Z-score, and typically this Z-test are used in this sort of a scenario. So either when you know the population data variance, variance or standard deviation, if you know that, then you can prefer Z-test. If you don't know the population variance, but if your sample size, the data that you're dealing with, if it is greater than 30, in that case also you can use Z-test. So these are the two conditions which are recommended if you have to use Z-test. Normally, while performing a Z-test, we calculate a metric called Z-score from the sample data. We will see how to calculate that and all, and we will compare that Z-score to a critical values, which basically tell us, hey, if a particular sample statistic, if it is falling in a critical region, rejection region, or non-rejection region. And there are also, under Z-test, there are two types or in fact variants of Z-test, depending upon type of analysis that you are trying to make. And these are normally called as one sample Z-test and two sample Z-test. We will see what these are with an example. So one sample Z-test is basically when you have to compare a single sample's mean with a population mean. So let's say you want to just estimate a particular, hey, what could be the mean of a particular situation in comparison with its population mean. So for example, this could be, if you see this example, determine if the students on an average score higher than 600 in an exam, right? So this, we have a single mean that is the average of the score, and we are comparing that with the value that is 600, right? So it's a single sample comparison with the particular number. So we call this type of the Z-test that which we use in this example or this type of a scenario, we call it as one sample Z-test. Let's say for the same example, we have, let's say, to take this example forward, let's say we have some other data that we need. First, in order to perform Z-test, we need, as I said, standard deviation or variance of the population, right? Let's say for that particular standard deviation in this example be 100, and let's say we take a sample from the population of 20 students, and the level of significance at which we want in this particular hypothesis, let's take it as 0.05. Now once that is done, we have already a sample data of 20 students and their marks, so we will calculate our sample mean. Let's assume that it to be 641, and we are comparing this particular sample with a mean of with a 600, so we will take population mean as 600, and based on this data we will build the hypothesis, null hypothesis and alternate hypothesis as follows. So we want to prove that if the students on an average score higher than 600, so we will take our null hypothesis as a negate of that, and we will say our null hypothesis mean is actually less than or equal to 600, and the rest becomes the alternate hypothesis. So as you can see, this is a one-tailed test, and let's see how to, in this particular type of hypothesis testing, in this particular for this particular scenario, let's see how do we calculate the Z-score and get our hypothesis results. So first, just give me a minute, please. Okay, so first we need to calculate the z-score, and z-score is calculated with a formula something like this. So we have a sample and a sample mean, okay, sample of 20 students, right? And we have a population mean against which we are comparing the sample mean with, and we have a population standard deviation. We know this particular variable, and n is nothing but the sample size at which we are referring to. Using this formula, we will calculate a z-score, and in our example, if we apply the same formula and all the values that which we saw previously, we will get the z-score of 1.8336 for our particular example. Now from this z-score, now we need to identify critical region. So z critical value for the rejection region. So based on that, if my z value is falling above my critical region, we can say that it's in the above my critical value, we can say that it's in the critical region. If it is not, we can say that it's not in the critical region. So that would be one possible test, or otherwise we could, from this z-score, we could calculate the p-value, and based on p-value also, as we have seen in the last session, we can say if it is less than a level of significance, we will go ahead and reject the null hypothesis, otherwise not. So there are two ways that we can go ahead from here. So first, let's see how do we calculate the p-value. Okay, so for that we take help of something called as z distribution tables. These are statistical tables. Let me share those first. So remember, our value z-score is 1.8336. So what we'll do is we will go to this is the z distribution table, okay, and we will identify the one-tailed distribution, and we will navigate ourselves to 1.8. So this is the z value 1.8, and on the right we have to go to the right column to get 1.83. So here we see that 0.9664 is a value that which it is showing at a z-score of 1.83. So our value is 1.833, but this should be sufficient, good enough approximation. So what this value 0.9664 tells us is you can take it as the probability of value falling in the shaded region. So that is the acceptance region, not the critical region. So if you subtract this particular value from the entire area, which is 1, so that is 1 minus 0.9664, we will get the white region, which is the critical region, and that would be our p-value. So if you would go ahead and coming back to our presentation, remove that 1 minus point whatever the value that we found, we will get the p-value as something like this. Okay, so that is one way we can do the p-value calculation, so using the statistics tables. The other way we can do is, there are you don't have to rely on those tables these days anymore. There are calculators and packages that you will find everywhere. So this is something an online calculator that which I found. Okay, so for the z value of 1.8336 which we have, I set up the other parameters, like my level of significance is 0.05, and I'm doing a one-tail test. So, and if I click calculate, I'll get my p-value to be 0.033357. And obviously, so that is one way. So given that p-value, I can go ahead and say that, hey, my p-value is less than my level of significance, which is 0.05. So I would go ahead and make a decision based on that to reject the null hypothesis. So that is one way using p-value. The other way would be to actually calculate the critical value in terms of z-score itself, instead of making comparison using p-value. So we already know z-score for our sample. So for a level of significance at which we have chosen, there is a way to calculate critical value in terms of z-score itself. So let me share that first. So yeah, so if you would notice in the same table here on the top right, okay, there are few sets of values, and these are the critical values at the different levels of significance. So if you notice, so this 5%, 2.5%, these are the numbers that are basically significance, and the alpha values that are represented here, and my alpha is 0.5. So no, my alpha is 0.05. So, and my C value here is 3.291. So just a minute, I think we are looking at here. I'm sorry. So 0.05 is a percentage. We have a alpha as a 0.05 in absolute numbers. It's not a percentage. So our alpha 0.05 is actually 5%. So it corresponds to the first value here. So that means this particular Z value would be our critical value. So anything that is greater than this would fall as in the critical region. Anything less will be in the acceptance region. So 1.645 is our critical value. So we'll go back, and based on our alpha, we'll get that particular 1.645 value, and we can say now, hey, my Z score is for my sample is less than. I'm sorry, it's in. Just a second, guys. Okay, hold on a minute. So we're doing a less than test. So critical value is that. So for the time being, we'll hold the analysis from the critical value point of view. We'll go with the p-values point. I'll come back to the critical value. It's likely I might have been missing something. So we can see that the p-value at the moment is less than 0.5. So that means, based on our analysis, previous discussions, we know that we can go ahead and reject the null hypothesis and accept the alternate hypothesis. So that basically tells us that our students on an average scored greater than 600 marks. So this is one sample Z-test where we are comparing a particular sample mean with the actual population mean, or a particular number. And the two sample Z-test is also similar, but instead of comparing to a particular value, we are comparing means of two samples. So let's say instead of group 1, we have instead of single group, we have two groups of people, and we are saying that, hey, group 1 students on an average score 10 marks more than group 2 students. And let's get some sample data for a similar same example. Let's say now, obviously for Z-test we need to know standard deviations, so we get standard deviation for both the groups, group 1 and group 2, and we take a 20 sample of 20 from both the groups, and we keep this level of significance as same, 0.05, and we get the sample means as well, 641 for one first group and 613 for second group. And so our statement says that, hey, the difference between mean 1 and mean 2 should be at least 10. So based on that, we will go ahead and construct these null hypothesis. So we want to prove that the difference is greater than 10. So null hypothesis will be less than or equal to 10, and alternate hypothesis will be greater than 10. So based on, for this particular example, so we will go ahead and calculate again Z-score. So in this case, the formula for calculating Z-score is slightly different. So we have to take into account two sets of statistics, sample statistics, means and standard deviations and sample size. So using this formula, we will calculate the z-score for our particular example, which turns out to be 0.588, and we'll go ahead and calculate the p-value for our 0.588, and level of significance is that, and it's still a one-tail test. So though we are dealing with two samples, it's still a one-tail test. We'll select one-tail test and we'll get the p-value to be 0.27, which is actually greater than our level of significance 0.05. So that means that we fail to reject our null hypothesis. So that would be our p-value, and p-value is greater than 0.05. That means we fail to reject the null hypothesis. We don't have enough evidence that, hey, on an average, students of group 1 score more than 10 marks compared to students of group 2. So this is a these are the two variants of tests that which we have under z-test. One when we are comparing a single sample with the population mean, or when we are comparing two samples. And similarly, we have t-tests as well, which is also pretty similar to z-test. We'll take a look at them as well. So these t-tests are normally performed when we do not know the population variance, so which is a key metric for us to calculate the z-score. So if we don't know population variance, we cannot perform z-score. So as an alternative, when we don't know population variance, we will perform t-tests, either that, or when a sample size is I think it should be less than the large is not supposed to be there. When the sample size is actually less than 30, you should prefer t-test. So, and just like how z-test are performed, we calculate something called a t-score. Sorry for that. So we calculate something called t-score, and then use that to calculate p-value, or use that against critical values to make our decisions on hypothesis testing. So similarly, we have one sample t-test and two sample t-test. We'll quickly go through them. They are kind of mostly similar to what we have done on the z-test, but slightly different. We just we'll go through them. So on a one sample t-test, again, we use a comparison of sample mean, single sample mean with the population mean. Let's take the same example as earlier. And at the moment, we have to understand we'll perform t-test when we do not know the standard deviation. So we do not have this data at the point, but we have rest of the data. Let's say we have to sample of 10 students, and we got their data, their marks, and the level of significance, let's call it as 0.05, and sample mean and sample standard deviation. So earlier we used population standard deviation, but here we calculate sample standard deviation. Let's call it S, and this is the population mean that which we are comparing our sample against. So based on this data, we will construct our null hypothesis, which is actually same as earlier. So we are checking if my average on a student score greater than 600 or not. So based on that, we'll construct null hypothesis and alternate hypothesis. And now let's see how to calculate the t-score, and based on that, how do we make a decision. So it's a fairly similar formula for t-score and z-score. So earlier we used to calculate using in the denominator, we used to have standard deviation of population, but here since we do not have that information, we will go ahead and use the standard deviation of our sample. So that's the only change between t-score formula and z-score formula. So we'll go ahead and calculate the t-value for our particular example, and it turns out to be 1.64. Now from this 1.64, now we have to again calculate critical value, and p-value can also be calculated from this 1.64. Let's quickly go see that, and Okay, so this is the Z table, and if you scroll down, we will also get something called as T table. Okay, and this T table is first we will identify the critical values. Okay, so what should be the critical value? So we'll select one tail test, which is our hypothesis example at the moment, and my level of significance is 5%. So so I need to go in this column, the first column, and I have, there is something else called as degrees of freedom. Degrees of freedom it is nothing but the it's a, you can call it as like number of the sample size minus 1. Since our sample size is 10, so we need to our degrees of freedom would be 9. So in this one tail test, 5% level of significance, on a degrees of freedom of 9, I have my T critical value to be 1.833. So this would be my critical value, and if I go back, so that would be my critical value, and my t-score is less than, I can see that t-score is less than critical value. Now let's see how do we calculate p-value from this particular t-value of 1.64, so that we are familiar with making decisions based on t-value. So we will go see that quickly. So what we need to do is we need to find in the degrees of first for here. So it's a same table. So just for explaining purposes, I've switched here. So degrees of freedom is 9. So I know this. So I'll look into this particular column, okay, and I'll see where the values change from our particular key value. So my value is 1.64. So I'll identify where my 1.64 could lie. So I'll come here, and the initial first value is 1.383, and my second value is 1.833. So my t value will lie somewhere in between these two values, right? So that means I need to take whatever the alpha values are there on the top, signal of significance 0.1 and 0.05. So I should think that I can approximate, hey, since my t value lies in between these two values, my p value lies in between these two values. So I can take some proportionate values based on how far my actual t value is from both these values, and I can do the same proportion here to get the p value. So in between 0.01 and 0.05. So we can do that using t values distribution, or we can also rely on some calculators like this. So I set up my t score is 1.64, my degrees of freedom is 9, and my level of significance is 0.05, and one tail hypothesis testing. So once I click, it will give me a p value of 0.06, 0.77. So if I go back to my PPT, so my p value is some 0.0678, which is actually greater than 0.05, our level of significance. So we fail to reject the null hypothesis, and saying that, hey, actually here we do not have enough evidence to prove that students actually score more than 600 marks in an exam. So this is the t-test. Earlier we using the z-test, we proved otherwise. It has nothing to do with the type of test. It's just in z-test example and t-test example, we have used different data. So the values, the sample mean, and etc. I've changed a little bit just to get us to these results. Okay, but yeah. So, and likewise, we have a two sample t-test where we compare means of two samples. Let's take the similar example here. Group 1 and Group 2, we have two sets of students, and we are saying that Group 1 students on an average score 15 marks more than Group 2. So we populate, we get all the rest of the data that which we know. We do not know the sample standard population standard deviations. We take a sample of 10 students from each group, and we specify our level of significance. We calculate our sample means and sample standard deviation, and we we are stating that, hey, the difference is will be greater than should be higher than 15, at least 15. So we will, based on that, we will also construct a null hypothesis and alternate hypothesis. Difference is less than or equal to 15, and we will go ahead and for 2 sample t-test, the formula is pretty similar to 2 sample z-test. We just replace the population standard deviation with sample standard deviation in the denominator, and we calculate the t-score. Our t-value, our critical value will not change. This is the same value that which we had in the first 1 sample retest as well, because it is solely dependent on the level of significance. If we change the level of significance alone, the critical value will change. Since we have carried the same level of significance, critical value will also carry. And in this, from this sample, we are getting that our t-value is 2.223. So we'll go ahead and calculate our p-value again for this, 2.223. My degrees of freedom is 9, significance is 0.051 tailed, and I get my p-value to be 0.026. So I'll come back here. So my p-value is 0.026, which is less than my level of significance. So I'll go ahead and say that we can reject the null hypothesis and conclude that my alternate hypothesis is true. There's a typo here. It should be actually 15 in the in these hypothesis statements. So we can state that group 1 is actually able to score on an average 15 marks more than group 2 students in the exam. So these are the this is how we perform z-test and t-test, use those scores to get p-value, and based on that we make either we reject the null hypothesis or accept the alternate hypothesis. So that is about this z-test and t-test. Just to summarize when to use which type of test, z-test and t-test, this is the broad. You can whenever we have a sample size which is larger or considerably greater than 30, you can go ahead with either z-test or t-test. Okay, so t-test is preferred when you have sample size is less than 30, but it's not like you cannot use it when you have sample size greater than 30. So z-test or t-test, if you have a larger sample, they both converge and tend to give you the similar results. So when a sample size is larger, you can go ahead for any test, but if it is not, then you have to see if you have the population variance information or not. If you know the population variance, you can go with z-test. If you don't know the population variance, then you have to go with the t-test. So this is the broad about like how we use z-test and t-test to conclude about hypothesis testing.